Hello everybody, this is Qingqing Liang. Here I will continue to talk about my capstone project, brain aneurysm detection using 3D cerebral angiography dataset. I have used PointNet to conduct aneurysm detections. Here I used a transformer for aneurysm detection and would like to see if the performance can be improved. As we know, unlike the typical 2D images, the 3D point cloud cannot take advantage of the traditional convolution network because of its unstructured dataset. The permutation-invariant nature of transformer makes them suitable for 3D point cloud. Here I briefly compare PointNet with a transformer. PointNet has multiple layer perceptron, max pooling, and rigid transformation, which including rotation and permutations. For transformer in natural language processing, we know it's mainly a decoder-encoder structure, which including three main modules: input or word embedding, positional or order encoding, self-attention, which is the core component, and it's generated with a refined attention feature for its input based on global context. Take the sum of input and the positional encoding as an input, and compute uses three vectors for each word. Query, key, and value are the three vectors that go through trained linear layer. Recently, a transformer for point cloud has been proposed. This transformer is called PCT, which shares the same philosophy of design as the original transformer, except the positional embedding is discarded. Since the point coordinator already contains this information, PCT includes the coordinator-based encoding embedding module, optimize the offset attention module, and the neighbor embedding module. The PCT has three pipelines: encoder, classification, and segmentation normal estimation. I will focus on the encoder and the classification in my project. The PCT transformed the input point into a new dimension feature space which will characterize the semantic affinity between points as the basics for the various point cloud processing tasks. Then, the embedding feature are fed into four stacked attention module, which is called offset attention, which are here to learn a semantically rich and discriminative representative for each point, followed by a linear to generate the output feature. At last, neighbor embedding will make the local neighborhood information, which is also essential in point cloud learning. Compared to the regular transformer, PCT uses modified self-attention, known as offset attention. Here I just briefly introduce self-attention itself, which is the base of transformer. The input is first converted to key shown in orange, query shown in red, and value shown in purple, respectively. In PCT, the matrix used for generating the three vectors are YD convolution layer. The score that is a scalar for each input is generated by the dot production of the key and the query. The score for each word are normalized by a softmax function. Then the value vectors are weighted by multiplying the softmax scores. The output is the addition of all the weighted values. The offset attention layer in PCT calculates the difference between the feature from self-attention and the inputting features using element-wise subtraction. This is adopted from graph network using Laplacian matrix to replace adjacent matrix E. D is diagonal or degree matrix. The offset attention layer can sharpen the attention weight and reduce the influence of noise, which is beneficial for downstream tasks. This diagram shows the architecture of offset attention. The first part of offset attention includes the regular self-attention. After getting the attention feature that is labeled as purple square, the attention feature is subtracted by the input feature. Then the offset attention feature undergoing LBR layer. The final output is adding of processed offset attention feature and the input features. PCT with point embedding is an effective network for extracting global features. However, it ignores the local neighborhood information, which is also essential in point cloud learning. PCT also adopts a local neighbor aggregation strategy is to augment PCT's ability of local feature extraction. In this module, there are two LBR which act as the basis point embedding in, and two SG sample and grouping layers gradually enlarge the reception field during feature aggregation as is done in CNNs. Here is how farthest point sampling algorithm works. It will downsample points. In the SG layer, there are two steps. The first one is farthest point sampling algorithm to downsample points. For each sample point, extract its key nearest neighbors. For each neighbor point, delta F is the difference between the features of the neighbor points and the corresponding sample points. Then the delta F of the neighbor points for one sample point were concatenated. To let the sample point to have the same dimension as the concatenated delta F features, the feature of a sample point is repeated k times to form a matrix. Then the output feature is calculated by max pooling the result from the LBR of the concatenated features. The parameters I used here is soft cross entropy loss function. Batch size is 32. Epoch is 150. SGD with momentum 0.9. Initial learning rate is 0.01 with cosine annealing scale to adjust the learning rate at each epoch. Here is the valid accuracy and the training loss. In valid accuracy, we can see the 110 epochs it turned to highest. But when we saw the train loss, it is still decreasing. Around 145 epochs, it began to be flat, which means 150 epoch is good. Test accuracy is 0.87 according to the highest accuracy model. The aneurysm is still around 0.48. AUC is 0.91 in this PCT, which is higher than 0.net. Here is the references. Thank you. If you have any questions, please email me, or if you need more details on my project, please check my GitHub.